Hey everybody, so we're going to be working on the monitoring progress example. I believe this is the last one of the section. And so we have to write another coordinate proof. So we were given this image here and the coordinates of all these vertices. As we can see, we have triangle NPO. So NPO is this top triangle, and NMO is this bottom triangle, and we have to prove that they are congruent. So one thing I noticed, unlike the last example, we don't really have any parallel lines of any sort. So we're probably not going to be needing any angles here. So let's start by finding out what each length of the segments are. So first I'm going to find the length of segment NP and NM. So actually I'll call it PN and MN just so that we can get corresponding sides. So if I want to find the distance of PN, we have to use the distance formula. So we have to use this formula here to figure out what the distance is between them. So if I'm using P and N, I'm doing the square root of x2 minus x1. In this case would be h minus 0 to the second power plus y2 minus y1, or h minus 2h to the second power, and then the square root of all of these. So now we're going to simplify, and so this is equal to the square root of h minus 0 is just h to the second power is just h to the second power, plus h minus 2h is going to be minus h to the second power. But a negative number to the second power turns into a positive, and so we have h squared plus h squared. And so I'm going to continue simplifying. These two are like terms, so we get 2h squared. And then using the properties of square roots, we can actually separate these like this. The square root and the square of something are inverses, so they cancel each other out, and we are left with h square root of 2 as its distance. So this is the distance for Pn. I'm going to try and find the distance for Mn and see if it measures the same distance. So if I do Mn, I'm going to use the same formula. So this is the square root of, and so Mn is going to be x2 minus x1, so we have 2h minus h to the second power plus y2 minus 1, y1, which is 0 minus h to the second power. We're going to simplify. 2h minus h is just h to the second power plus 0 minus h is minus h to the second power. But as we see, like before, we're going to be getting the same thing. And so I'm just going to skip all the way to this part right here because it is the same process. So it turns out Pn and Mn do have the same length, and so we can say that segment Pn is congruent to segment Mn. Alright, so that's our first one. Now the other length that would be the easiest to calculate would be the length of MO and PO. Remember, if lines are horizontal or vertical, it is going to be really easy to figure out what their length is. All we have to do is count. So for MO, the length of MO is going to be just 2h minus 0, which is just 2h. And I'll do it like the last example. 2h minus 0 is just 2h. And I'm going to do the same thing for PO. And so PO, all we have is, once again, the y value is now 2h minus 0. And so that is just 2H again. So from this, we know that MO, segment MO, is congruent to segment PO. So we have a side, we have another side. We might need to find one more side so that we can prove that these two triangles are going to be congruent. And just like before, we're going to notice that if we look at segment ON, we see that by reflexive property, of congruence, we have that ON, segment ON, is congruent to segment ON because they are the same segment. So now we have a side, and a third side. We are now able to say, so by side congruence theorem, we have that triangle NPO is congruent to triangle NMO. And we are done with this coordinate proof.